Hello everyone. This series of videos is to introduce the functions of GWINSTACK C-3200 LoRaWAN tester and how it is installed and operated. This video introduces how LoRa software controls C-3200 to be a LoRa signal generator and spectrum analyzer. Please complete the C-3200 network connection and settings first. If it has not done so, please refer to the second video. Connect the C-3200 with the PC. After the connection is complete, execute LoRa software. First, the transmitter function of C-3200. Now, C-3200 is a LoRa signal generator. Select transmitter C-3200 as SG under non-signaling test to set LoRa parameter setting, LoRa packet editing, and LoRa output setting. After completing the settings, the LoRa signal is output by RF port. Click LoRa setting to set all parameters, including frequency, PA ramp, data mode, spread factor, bandwidth, coding rate, and IQ invert, implicit header, and payload CRC. In LoRa packet editor, you can set the preamble length, payload length, and edit the payload data content. When editing, you can also arbitrarily choose to enter it in the hex or ASCII field, and the corresponding ASCII or hex code will be automatically displayed in the other field immediately. The transmission power can be set in the LoRa output setting. The range is 0 dBm to minus 150 dBm. And other settings include the number of repeated transmissions and interval time. Now, the parameters of the C-3200 transmitter are all set. Click Start, and the LoRa signal will be generated from the RF port. After setting the aforementioned LoRa parameters, the transmitter timing specification will be calculated and displayed. This is the ideal value and used as a reference for LoRaWAN design and actual deployment. Next, the receiver mode of C-3200, that is, C-3200 is used as an advanced spectrum analyzer or LoRa signal analyzer to receive, analyze, and demodulate LoRa signal. Select receiver C-3200 as SA under non-signaling test to perform LoRa parameter setting, data format setting, and trigger setting. After completing the settings, the LoRa signal can be received by RF port for analysis and demodulation. LoRa settings include frequency, spread factor, bandwidth, coding rate, preamble length, and on or off of IQ invert, implicit header, and payload CRC. In the data format setting, you can set symbol format, Gaussian filter on-off, and its bandwidth time product, and number of symbol period, RBW and IFBW. The IFBW must be wider than the received signal's bandwidth. The bandwidth in the LoRa settings is 125 kHz. So the IFBW here is 300 kHz. The RBW setting will affect the spectrum shape and sweep time displayed in the frequency domain results. The larger the RBW, the more circular spectrum shape and the faster sweep time. Trigger setting is to set the conditions of the capture signal, including trigger level, delay time, and trigger mode. After completing the settings, click Trigger Start to start the measurement. The measurement result includes the modulation signal of the time domain. This result is very important and helpful. You can check whether the chirp spread spectrum modulation is normal. Frequency domain measurement result can check whether the RF performance, such as frequency, amplitude, etc., is normal. The received data and the related LoRa parameters will be displayed here, such as bandwidth, TOA, time on air, FEI, frequency error indicator, symbol rate, DUT transmitting power. The test result can be exported in PDF or BMP format. This video ends here. Please continue to watch other videos. Thank you.